This is lesson 4.3, multiplying and dividing monomials. We'll start with multiplying. The steps are pretty simple. To multiply monomials, first you're just going to multiply the coefficients together, or the numbers that are in front of the variables. Then when we're dealing with the variables, if they are the same letter, then you can add the exponents together. And this is actually our multiplication exponent law that we did in chapter 3. If the bases are the same and you're multiplying them, then you can add the exponents. So if we had x to the 5 times x to the 2, they both have a base of x, so that would give us x to the 7. That's the same idea that we're doing here. But if they are different variables, then you can't do any other simplification. Your exponent laws don't work there, so just write them beside each other to represent that they're being multiplied. So in this example, the coefficient will become -12 because we multiply these two coefficients together. But since x and y are different variables, we just leave it as x times y. No further simplification can be done because they don't have the same base. A couple examples for multiplying. So 3x times 4x, multiply 3 by 4 to give us 12, and x times x gives us x squared because we added those x exponents because they have the same base. And remember, when a variable does not have an exponent written, it just has exponent 1, but those are the invisible ones that we don't have to write, but it still is there. For this next example, -2 times 5 gives us -10 out front. Don't forget our sign rules. When we have one negative and one positive, it is overall negative. And then we add the exponents of the variables to give us x to the power of 3. And this last example, multiply our coefficients together. Remember this negative times this negative gives us overall a positive value. And then when we look at the variables, we see we have x and y squared. They're not the same letter, so there's not much simplification we can do. We just write them all lined up together to represent multiplication. So x times y squared. Division is very similar. You're of course going to divide the coefficients instead of multiplying them. And we're going to use our division exponent law. So again, if the variables are the same, then they have the same base, so we can subtract the exponents. So in this example here, 12 divided by 3 gives us 4, and then the variables are the same, so we can subtract the exponents to leave us with x squared. Again, if the variables are different, just leave them as they are. There's no other simplification that we can do because they don't share a base. Couple examples of division. First one here. Divide the coefficient, 6 divided by 3 gives us 2. And then x squared over x is the same as x squared over x to the 1. So when we subtract that, we're just left with 1x on top. Another way that you can think about that is if you have x squared on top, it's x times x, and then a single x on the bottom. So this one can cancel out with this one. Because anything divided by itself is just 1. So they cancel each other out, leaving you with just 1x. In this example, 8 divided by 2 gives us 4. And then we've got xy divided by y. In other words, xy over y. So the x just stays as it is because there's no matching variable to it, so we can't simplify it anymore. And then we're left with y over y. Those cancel out because they divide each other out. And then we're just left with the x on top. Last example, 15 divided by 3 gives us 5. For our x's, we subtract the exponents. So 3 minus 1 gives us 2. And for our y's, same thing, 2 minus 1 gives us 1. Last two examples, kind of bringing it all together when we have multiplication and division in the same questions. So this one, it doesn't actually matter if you do multiplication first or division first. The numbers all work out kind of nicely. I'm going to do multiplication first, but you technically could divide like these two together first, or you could have divided these two together first. But I'm going to do multiplication. So -2 times 3 gives us -6. And then the variables are matching. They're both x. So we just add the exponents to give us 5. Now we just have a division question left. So divide these coefficients, and don't forget about that negative. -6 divided by 6 gives you -1. And then we subtract the exponents on the variable to leave us with x to the 4. For this example, again, it doesn't technically matter if you do multiplication first or division first, but in this example, it makes more sense to do the multiplication first. Because if we did the division first, if we did this first, -4 divided by 10 doesn't give us a nice number. It doesn't give us an integer. That would be a fraction, and that's a little harder to work with. So let's do this first and then do our division. 5 times -4 gives us -20. Don't forget those sign rules. And then we've got m squared and n. These do not have the same letter, so we just leave it as they are. There's no more simplification. Now we can do our division and the numbers work out well. -20 divided by 10 gives us -2. For our m's, we've got m squared divided by m. So when we subtract those exponents, we're just left with one single m. The n stays as it is because it doesn't have any pair. There's no simplification. There's just one n. So then this is your final answer. So you can I use X and Y and Z a lot for the letters, but sometimes you might see M and N or ABC, but any of the letters can work. So that is how you multiply and divide monomials.